Okay. Okay. Bismillahirrahmanirrahim. Okay. Okay, right now I'm presenting. Can you see my
Yeah, we can see.
screen?
Yes,
Yes, teacher.
yes, teacher.
Yes, teacher.
Yes.
20. Ya, Afi, Alia, Amira, Atika, Dahlia, Hamad, Harith, Atis, Adam, Muhammad Mirza, Muhammad Zarfan, Nur Ain, Nur Aisyah, Nur Duratul, Nur Huda, Nur Muhammad, Nur Zafrin, Nur Indiana, Putri Dayana, Putri Anis, Renisha, Winkana. 23. Okay, never mind. Okay, we will proceed with this topic. So we have discussed about reactivity series of metals 4.2. Okay, how this reactivity series is constructed based on the vigorous reaction between these metals, and oxygen. So depend on the vigorosity of the reaction between metals and oxygen, so we can construct the reactivity series of metals. So based on this one, if you see this diagram, so reactivity of metal toward oxygen increase from left to right. So from here we know that potassium, the symbol represent potassium is K, sodium Na, calcium. So this is among the most active metals when react to oxygen. So and the lowest or the most the less reactive metals is aurium or gold. Okay, so based on the reaction of these metals toward oxygen, so we can know which metal is more reactive and which metal is less reactive. Okay, so next we want to see the different or the other non-metals, exactly two elements that are not metals but is put into the reactivity series of metals. Why these two elements that is not metal but can be put into this reactivity series? Because these two elements that is non-metal can react vigorously toward oxygen. So based on this reactivity of these two elements, so we put these two elements into the reactivity series of metal, even though these two elements is not metal. So the two elements here is carbon and hydrogen. So these two non-metal elements, carbon and hydrogen, even though these two non-metal element is not metal, but we have to put into the reactivity series of metals because they can react with oxygen, and also they can react with the metals or the substance or the compound of these metals. Because of this special reactivity towards the metal substance or metal compound, so that's why the scientists put these two elements into the reactivity series of metal. So what we are going to discuss here, how this carbon and hydrogen is determined into the reactivity series of metal. So we want to see the experiment that show on how we determine the position of carbon and hydrogen into this reactivity series of metal. So these two activity or these two experiment, the first one is the position of carbon in reactivity series of metal, and also the second experiment that is this one, experiment or activity to determine the position of hydrogen in reactivity series of metal. These two experiments, you have to try to understand and try to remember the procedure on how to conduct the experiment. Because this one very important for you, because it is always asked in the question, the syllabus that give important concept to the constructing of the reactivity series of metal. So we will look into these activities, two activities, and how these activities can conclude about the position of carbon and hydrogen. So the first activities, how we determine the position of carbon in the reactivity series of metals. Okay, so if you can see from this, okay, the aim of this experiment to determine the position of carbon in the reactivity series of metal by heating the following substances. Okay, so the first one, A, zinc oxide. Okay, this one is zinc oxide. Okay, we will react zinc oxide with carbon. Okay, so we put together zinc oxide and carbon and we react them together. We want to see what exactly happen when these two substances is react, is mixed together. The second is aluminium oxide react with carbon, and the third one is lead 2 oxide react with carbon. So by doing this, the reaction between carbon and three of the metal compound. So this one we call it as a metal compound because zinc oxide, aluminium oxide, lead 2 oxide is a compound. So you must remember, revise again about what is the meaning of compound. So compound is any substance that consists two or more elements combined chemically together. So zinc oxide, aluminium oxide, lead 2 oxide is a compound or metal compound because one of the element is metal. Zinc oxide, aluminium oxide, and lead 2 oxide. So this metal compound, we will react with the carbon and we try to observe what happen when carbon react with the metal compound. So from this reaction, we want to know between carbon and the metal of this compound, which one is more reactive. So if zinc oxide that react with carbon and the reaction occur, the reaction occur means that carbon is more reactive than zinc metal itself. So when zinc oxide, so you have to understand this one because this is a chemistry concept. So when zinc oxide can react with carbon, so zinc oxide is a compound, carbon is an element. So when an element can react with compound, means that that element is more reactive than the compound itself. And if nothing happen when we mix the compound with carbon, so for example, aluminum oxide, when we mix with carbon, we heat the mixture and then nothing happen. So if there's nothing happen, means that the carbon cannot react with aluminum oxide, and this means that carbon is less reactive than the aluminum itself. So that is the thing, that the concept that you have to understand based on this experiment. Okay, so now we look, the material, carbon powder, zinc oxide, aluminum oxide, and lead 2 oxide. So we are using 4 materials, four chemical substance here. Okay, the apparatus is crucible, spatula, Bunsen burner, pipe clay triangle, and tripod stand. So all these materials and apparatus that you must remember. Okay, so the instruction given here, from the diagram shown here, you can see, this crucible, so we will put into the pipe clay triangle on the tripod stand. So this one is a tripod stand. So we have crucible here. Okay, inside the crucible, we will put the substances that we want to react. We will put carbon powder and the metal oxide. So we put here and then we will heat from the bottom. So we put Bunsen burner. So the heat come from the Bunsen burner. Okay, so by heating the crucible, so we can make the mixture of carbon and metal oxide react faster, because in a high temperature, the chemical substance can react quickly, compare if we're not doing that, the heating process. Okay, so this is the diagram. So when we heat, we want to see, we want to observe what exactly happened during the heating process. If there is the reaction between carbon and the metal oxide, so from here we can conclude which one is reactive and which one is less reactive. So we will mix carbon with 3 metal oxide, zinc oxide, and then we replace with the aluminium oxide and then lead 2 oxide. Okay, so after that, observe the changes that happen to the mixture. Record your observation in a table. Okay, now the observation here when we heat the mixture between zinc oxide and carbon. So we have to write here what is the observation and then what we can conclude from this reaction. So we can say if the reaction happen, so we can say that the carbon is more reactive than zinc. Same here, if carbon and aluminum oxide, if we observe that the reaction occur, so we can say that the carbon is more reactive than the aluminum, for example only. And same thing with the third mixture. If there is a reaction between lead 2 oxide, so we can say that the carbon is more reactive than the metal itself. Okay, so from here, okay, sorry. Okay, so what exactly happened? What we can observe from this one? Before that, so I want to show you about this one, a word equation. For each reaction of metal oxide with carbon. Okay, so when there is a reaction, so we have to write the chemical word equation that represent the reaction between the substances. So for example, if we react zinc oxide, so we have to write zinc oxide, and carbon, so we have to write zinc oxide plus carbon. Okay, so both of these substances are substance that react. So the arrow here shows what is the product that is produced. So we have to write the product name here. The chemical substance we put here. Okay, same thing. So all the chemical reaction, we can represent the reaction by writing what we call as a chemical equation. So in your Form 3 syllabus, so we write the chemical equation in the form of word. So make sure that until now, you know when we ask you to write a word equation means equation is a chemical equation that represent the reaction between the chemical substance. So we look here, for example, we take this one, lead 2 oxide react with carbon. Okay, so what exactly happened? My digital pen not function. What happened? Okay. Okay, for example, so we call this one as a word equation Yeah, word equation. Okay, so for example, lead to oxide. Yeah. So lead to oxide, this is a metal oxide. Yeah. Metal compound. Yeah. So this one, metal. Okay. So metal oxide. So means that metal combined with oxygen to form compound, we call it as a metal oxide. So this is a general name. Yeah. So which metal that combine, so depend on the type of metal. So now we have lead to oxide. Yeah. So this lead to oxide, a compound, so we react with carbon. So when we react with carbon, we heat, yeah, in the process. So what will happen is, okay, so in this reaction, so reaction occur, yeah, and when the reaction occur, what will happen? Okay, so it will produce new substance, yeah. So when the reaction happen, it will produce a new substance, and then this new substance or the product is, okay, the first one is lead. Okay, lead and carbon dioxide. Okay, so it will produce lead. Okay, so from here we can know that this lead is a metal. Yeah. So, and then the second product is carbon dioxide. This is a gas. Carbon dioxide gas. So when lead to oxide, the metal compound, yeah, react with carbon. So what exactly happen is this carbon is that is more reactive. Yeah, it can reduce lead from the oxide. Yeah, so carbon that is more reactive can reduce lead from the metal compounds. That's why this oxygen, yeah, taken by the carbon, and then it will form carbon dioxide and left lead itself. Yeah, so that's why in this reaction, just a simple explanation, when carbon is more reactive than the lead itself, so it can take the partner of the lead, the partner of this metal, and it will form carbon dioxide. So this one, oxide is exactly oxygen. The element is oxygen. So carbon can take oxygen from the lead, in its compound. So that's why it just left lead only, and then carbon will combine with oxygen to form carbon dioxide. That is exactly what happened during the reaction between carbon and lead to oxide. Yeah. Okay, so this is the complete word equation. Word equation in the form of word. Yeah. Okay, why we put word here? So you have to understand exactly in chemistry, in SPM, so you are not required to write this word. You have to change the word into the symbol. Yeah. So for example, this lead to oxide, exactly the symbol is PbO. This one is a PbO, lead, oxygen. So this one is a lead to oxide, react with carbon the symbol is C, and lead is Pb plus carbon dioxide gas, CO2. So this is what we call as a chemical reaction. Yeah, chemical reaction. Yeah, chemical reaction. Chemical equation. Yeah, okay. So chemical equation we represent in the form of symbol, or we call it as a chemical formula. Yeah, okay. So this one you will learn in Form 4 in chemistry. Yeah. Okay, next example is aluminum oxide and carbon. Okay, we see aluminum oxide. So aluminum oxide, okay, react with carbon. Okay, so based on the experiment, if we react aluminum oxide with carbon, is there any reaction? So the answer is no reaction occur. Yeah, no reaction occur. So what does it mean? What the conclusion that you can make from this experiment when we react aluminum oxide with carbon? So we can observe that no reaction occur. Yeah, no reaction. Okay, so why is it happen like this? Because carbon is less reactive. Yeah, less reactive. Yeah, kurang reactive compared to the aluminium itself. So when these two substances mix together, because carbon is less reactive, so we can say that aluminium itself is more reactive. Yeah. So this carbon cannot take oxygen from the aluminium. That is the simple explanation. So to make you understand about the reaction between substance in chemistry. So when this carbon alone as element want to react with the compound, that combination of two elements. So if the carbon want to take oxygen from the aluminium, so the carbon must be more reactive than the another partner. That is the simple explanation on how to understand this one. So if the carbon is less reactive compared to the aluminium, means that the carbon cannot take oxygen from the aluminium. It is like a couple. Yeah, there is one less handsome boy. Yeah. So if this less handsome boy want to take the partner of this more handsome boy, yeah. So because of the less handsome, so this carbon cannot take the another partner of the couple itself. So that is the simple explanation why the aluminium oxide that react with carbon, nothing happen. Yeah, no reaction occur. Yeah. So that's why from here, from this activity, we can conclude that carbon is less reactive compared to the aluminium itself. Yeah. Okay. Yeah. Next, we want to look into the video about the reaction of metal with oxygen. Okay, this one is the first experiment to determine the metal reactivity of metal with oxygen. This one is not the carbon. Okay, so exactly this video I want to show you the last week, but okay, you can see from this experiment. So this is the reaction between metal and oxygen gas. So you can see the vigorous reaction, whether it is very reactive or not. Bunsen burner. Okay, so it will produce, for example, magnesium, and oxygen, it will produce magnesium oxide. Okay, potassium manganate, when heated, it will produce oxygen gas. So this oxygen gas will passing through the heated metal. Example given here is zinc. So zinc will react with oxygen. So we can see the vigorous, whether it's produce flame, this vigorosity of reaction, whether produce flame or just a glow, or what exactly happened to the product. Okay, this one is a lead powder. So you can see there's a glowing reaction. Okay, so that one is the experiment to show the reactivity of metals with oxygen. So now we will look into the position of carbon. Okay, in reactivity series of metal. Okay, so we take this one.
Grammarly does position of carbon in the reactivity series. Even though carbon is a non-metal element, it can combust in excess oxygen to form carbon dioxide. Oxygen is reduced to oxide ions, and the oxidation
Okay,
number
so
decreases
what
from
you
0
have to learn
2.
from this one is exactly
Carbon can act as
more
a reducing
chemistry
agent
than
to reduce
science.
the metal oxide to its metal. The metal oxide acts as the oxidizing agent to oxidize carbon to carbon dioxide.
We want only to look into
position
the
for carbon
how
towards oxygen
experiment is
in the
conducted.
reactivity series can be determined by reduction of carbon dioxide by more reactive metal. In this reaction, a strip of burning metal is put in jars filled with carbon dioxide gas. If metal is more reactive than carbon, it remains lit with a bright flame, producing black fragments and white powder. If carbon is more reactive than the metals, no reaction occurs. We also can determine the position for carbon towards oxygen in the reactivity series using reduction of metal oxide by carbon. In this reaction, a mixture of carbon and metal oxide is heated.
Charcoal.
If carbon is more reactive than the metal, a white flame
Charcoal
can
is
be
a
seen.
carbon.
Carbon will act as a reducing agent to reduce metal oxide into metal. If carbon less reactive than the metal, no reaction occurs because carbon is unable to attract oxygen
No
from
change
aluminum
happen.
oxide.
No reaction.
The position for carbon towards oxygen in the reactivity series is shown as follow. Any metal above carbon in the reactivity series can displace oxygen from carbon dioxide, as shown in the equation. Any metal below carbon in the reactivity series can be displaced by carbon from its oxides shown in the equation. Thank you for taking time to watch this.
Okay, so from this experiment,
This video will be looking at the position of carbon in the reactivity series of metal. We're going to find the position of.
okay, so from this experiment, okay, we can see that exactly, the first one, the first activity, zinc oxide and carbon, we can see that the reaction occur. Yeah, so means that we can write here reactivity of carbon, that carbon is more reactive than zinc. Yeah, so we can write here carbon is more reactive than zinc. Yeah. Second activity, aluminium oxide and carbon. So what we can observe is no reaction occur, means that carbon is less reactive than aluminium. Yeah. Then the third experiment, third activity, between lead to oxide and carbon. So we can see reaction occur. Okay. And then we can conclude that carbon is more reactive than lead. Yeah. So from here we can arrange, the reactivity series of metal in which carbon is put between zinc and aluminium. Yeah. Okay. So from here, okay, so number 5, underline the correct answer for the following statements. Yeah. A, if carbon can remove oxygen, okay, if carbon can remove oxygen from a metal oxide, I have explained to you how the reaction occur. If carbon can take oxygen from the metal oxide, means that carbon is more reactive than the metal itself. So that is on how we can explain the reaction that occur. B, if carbon cannot take the oxygen from the compound, so means that the carbon is less reactive than the metal. So based on this reaction, we can arrange the position of carbon between all the metal that exactly we conduct. So in this experiment, we only compare the reaction between metal of lead, zinc, and aluminium. So exactly we have to do with all the metal to make sure that the position is accurate. So that is the experiment about how to determine the position of carbon in the reactivity series of metal. Now we will look into the second experiment, second element, that is hydrogen. Okay. So we want to know what is the position of hydrogen in the reactivity series of metals. Okay. So the activity for this experiment is different, quite different from the activity to determine the position of carbon. So if you can see this diagram, okay, so how to understand, how to remember this one. I hope you can remember. Okay, I try to explain as simple as I can. So, okay, we start from the left. Okay, this one. Okay, we have. Okay, this one. We call this as a round bottom flask. Okay, not label here. Okay, never mind. We call this one as a round or flat bottom flask. Yeah. Okay, this flask, yeah, flat bottom flask will consist sulfuric acid, yeah, that mix with a copper to sulfate solution, and then zinc. Okay, what is the intention of putting these substances? Yeah, after this, okay, this is a funnel. We want to put all the material inside the flask. Okay, and then we have this one, a delivery tube. Okay, that connected from the flask, yeah, to this one. We call this as a U tube. Yeah. So this glass, U tube glass, okay, consists of anhydrous calcium chloride. And what is the function? Why we must put this anhydrous calcium chloride into the U tube? Okay, we will explain after this. Okay, and then connected with the delivery tube into the combustion tube. Okay, so inside the combustion tube, okay, we have this one. The most important thing is metal oxide. Yeah? So we put metal oxide in the combustion tube. Yeah, this one, combustion tube. Okay, so how to react hydrogen with the metal oxide? So we have metal oxide here. So hydrogen itself comes from the reaction of sulfuric acid and zinc. Yeah? So when sulfuric acid, this one, sulfuric acid, react with zinc, so it will produce one of the product is hydrogen gas. Yeah. Okay, this hydrogen gas will be produced in the flask, and then it will release and passing through the delivering tube. Yeah. Okay, and then the hydrogen gas is exactly wet, wet hydrogen gas. Maksudnya hydrogen gas lembab, consists of water, because another product for this experiment between the reaction between sulfuric acid and zinc is water. Yeah, so it will bring along water. So exactly the hydrogen gas is a wet hydrogen gas. So that's why we have to passing through what we call as a calcium anhydrous calcium chloride. So the function is to absorb the water molecule that attach to the hydrogen gas. Means that we want to dry the hydrogen gas. So when passing through the calcium chloride and enter to the next delivering tube, so we will get dry hydrogen gas. This one, dry hydrogen gas. Because we don't want to react this metal oxide with hydrogen gas that is wet, that consists, that attached along water, because the reaction will have a different reaction. That's why we have to make sure that the hydrogen gas we use in the experiment is dry. No water is bring along. So now when this dry hydrogen gas enter into the combustion tube, so hydrogen gas will react with the metal oxide that is being heated, in a porcelain plate. So when the reaction occur, hydrogen react with the metal oxide. So we can see, we can observe from this one, if the reaction occur, so we can say that the hydrogen is more reactive than the metal itself. If the mixture occur, if the mixture between hydrogen and metal oxide and no reaction occur, means that the hydrogen is less reactive than the metal itself. So this is how we conduct experiment to determine the position of hydrogen in reactivity series. So all the metal oxide, from the potassium, sodium until silver and also aurium is conducted, is put here, will be replaced here one by one to show whether that metal can react with the hydrogen. Position of hydrogen in the reactivity series of metal. So based on this experiment, so we have the observation concluded here. So you have exactly to remember this one. You have only to remember 1, 2, 3, 4, 5. Okay. For example, example given here, observation. Okay. When hydrogen and aluminium oxide react together, so what we can see, the observation is aluminium oxide does not glow. Aluminium oxide still in white color. So what we can conclude from this one? So conclusion. Okay, inference. The word inference here. Okay, inference. What is the meaning of inference? Inference is a explanation on observation. So we have observation. The observation is aluminum oxide does not glow, means that no reaction occur. So inference is the explanation why the observation is like that. So we can say that hydrogen does not reduce aluminium oxide. The sentence is given like this. Hydrogen does not reduce. So maybe you want to ask what is the meaning of reduce. Exactly, this is a chemistry term. Reduce or reduction, and another one, another term is oxide or oxidation. Reduce or oxidize. So it means this one exactly a little bit confused for you because this is the chemistry term. Never mind, just follow the word given here. Okay. So if the hydrogen, what can I say is, if the hydrogen is less reactive, if the hydrogen is less reactive, means that hydrogen cannot reduce aluminium from its metal compound. So that's why, because hydrogen is less reactive than aluminium, so no reaction occur. So next we look into the hydrogen react with the zinc oxide. What happened? Zinc oxide does not glow. Okay, so same with the aluminium, means that hydrogen cannot reduce zinc oxide. Means that hydrogen is less reactive compared to the zinc. Hydrogen and iron oxide. So the observation we can see here, iron 3 oxide burns brightly and reddish brown powder turns shiny gray. So we can observe that the reaction burns brightly. So from here means that the reaction occur. So we can say that hydrogen is more reactive than iron. That's why hydrogen can take oxygen from the iron oxide. Okay. Next is the hydrogen and lead 2 oxide. Okay, burns brightly, means that hydrogen can reduce lead to oxide to lead means hydrogen is more reactive than lead. Yeah. Last one, hydrogen and copper to oxide. So burns very brightly. So from here, we can say that hydrogen reduce copper to oxide to copper. Hydrogen is more reactive than copper. Yeah. So based on the observation and based on this experiment, so we can say that hydrogen is, yeah, hydrogen is less reactive than aluminium. The second one is hydrogen is less reactive than zinc. Yeah. Number 3, hydrogen is more reactive than iron. Hydrogen is more reactive than copper. Hydrogen is more reactive than lead. So from this experiment, we know the position and the vigorosity of hydrogen compared to the other metals. Yeah. So the conclusion from this activity, yeah, position of carbon and hydrogen in reactivity series of metal is that we can conclude that carbon, the position of carbon and hydrogen are given here, yeah, in which carbon, the reactivity of this is between aluminium and zinc, while hydrogen, yeah, hydrogen, the reactivity is between zinc and iron. So from this reactivity series of metal, so you have to remember the position of every metals and also the position of carbon and hydrogen. Yeah. So how to remember all this one from potassium, the arrangement of this, because potassium is most reactive metal, and the second reactive metal is sodium, next is calcium, magnesium, yeah, until the less reactive metal that is aurium, yeah, or gold, yeah. So how to remember this sequence, yeah? Okay, how to remember this one? Okay, I give you one way. Yeah. So as you know that potassium, okay, potassium, sodium, calcium, magnesium, aluminium, yeah. Okay, zinc, iron, titanium, okay, yeah. So okay, we have mercury between after copper. Okay, so I can give you tips, yeah, in exactly in BM lah, to make you easier to remember the arrangement of this metal in the reactivity series of metal. Okay, so we have carbon here and we have hydrogen here. Okay, so this one you have to remember carbon is between aluminium, okay, hydrogen. Okay, what we can make a sentence, yeah, like this. In BM exactly, kalau nak kalsium kawin M mesti A aluminium ada zakat fitrah S supaya perhubungan P cekal hingga abadi. Okay, that is my own sentence to remember the sequence of this reactivity series of metal. So kalau nak kahwin mesti ada zakat fitrah supaya perhubungan cekal hingga abadi. So you can make your own sentence to remember the position of each metal in reactivity series of metal. And then for carbon and hydrogen, you just remember it is between which metal. So this one, so carbon is between aluminium and zinc. Hydrogen is between zinc and iron. So that is the conclusion for this experiment about the reactivity series of metal. So this is on how we can construct the reactivity series of metal that consists also the position of carbon and position of hydrogen. Okay. So any question from you regarding this one?
How do we, teacher?
By looking at the reaction of the least reactive. So as we go down this list of metals, the reactivity becomes less and less. If you haven't seen the video on the carbon.
Hello?
Teacher, hello.
Yeah, hello. You can ask.
Do we have to do notes?
What?
Do we have to do notes?
Yes.
Okay.
Okay, same as usual. Yeah.
Exercise?
Exercise, same.
How we test the reactivity.
Okay,
Okay.
so same as before. So after we have finished discuss the any topic or subtopic, so all the
This time we test.
notes. Oh, sorry. So all the notes and also the exercise, for example, this one. So you must write it in your notebook. Yeah. Okay.
And
This
send to
format.
Telegram, teacher.
Yes. After that, you have to submit through my Telegram. Yeah. Okay. Same also exercise given in the process science book. Yeah. So please complete all the exercise given in the textbook and also in the module or the process science book. So make sure that until now we have reached 4.2. So make sure for today you complete all the notes and also the exercise given. Yeah. Okay, any questions? So tomorrow we will look into this one, 4.3, extraction of metals from their ores. Yeah. So any question from you regarding this subtopic 4.2? Any question?
No, teacher.
No, teacher.
Okay, now we have 26. 26 of you. Supposed to be 33. Monitor, please give me name for the absentees here. 26 means that we have 7 absent here. I cannot remember you. Yes. Please, monitor, give me their name. Okay, so that's all for today. So I hope that you can understand this chemistry concept, even though very difficult exactly. Yeah, but if you can understand this, that's very good. Yeah. So tomorrow we will discuss about the 4.3, and then also if we have enough time, so we will also discuss the question given in the textbook. Yeah. Okay, so that's all for today. Thank you very much. Okay, you can left this Google Meet.
Okay, bye, teacher. Thank you.
Thank you, teacher.
Teacher.
Thank you, teacher. Bye, teacher.
Okay, thank
Thank
you
you,
very
teacher.
much.
Thank you, teacher. Assalamualaikum.
Waalaikumsalam.
Okay, thank you very much, teacher.
Yes?
Thank you.
Okay.
Okay, thank you, cikgu. Bye-bye.
Sama.